What's up guys, Shawnthebro here, and we're back for another episode of the fighting game tutorial series. In today's episode, we're going to be cleaning up our projectiles. In the many recent episodes of our fighter game, we have been cleaning it up. Many things like the animation blueprint, the character, the game mode, lots of our logic, in many different classes so that we can get ready for rollback netcode and AI and story mode. And we're just going to be continuing on this trend today, so all the improvements that we're making are making it faster, easier to modify things and create additional functionality for, converting it from blueprints to code where necessary or beneficial, reducing redundant code, and cleaning up bugs. We're going to be continuing on with that today, but in our projectiles. So we have many different types of projectiles. We have homing projectiles. We have our horizontal projectiles, we have projectiles that come up from the ground, projectiles we can throw, and more. In the previous episodes, specifically going over the animation blueprint, and with the animation blueprint we cleaned up all of our hitboxes and the way we were spawning them and getting data to them, which is amazing and one I'm super happy about fixing. And although that method supports projectiles, projectiles are a little bit different by nature and I want to support them too, and we can improve them significantly by converting some functions to code, consolidating some logic, and fixing a few bugs. Like when we rotated the character as part of this cleanup, it may have thrown off your spear throw. So for example, if I try and use this scorpion spear attack, it's actually going the wrong direction now, which is not what we want. And it's going to block us because we're not going to meet any of our conditions. It's not going to go off screen. It's not going to hit the opponent. So we're going to need to fix that up as well. So we have a few different fixes for today's episode and many good improvements for our projectiles. Before we hop into today's episode, if you want to get caught up in the entire fighting game tutorial series to see how we've done things like multiplayer, online networking, hitboxes, collisions, and a whole lot more, I'll link you to the entire fighting game tutorial series playlist right here in the top right corner. Alternatively, if you don't care about that and you only care about projectiles, cleaning up your projectiles, making sure all your projectiles work with our current systems, or making new ones and doing that in C++, you've still come to the right place, but I will recommend that you watch at least the projectile episodes before this episode, as we will be building on top of that logic for today's content. So I'll link the first one there in the top right corner for you. We can go ahead and get started. So this is a code and blueprint tutorial series. We're going to be both in the code and the blueprints. We're going to be converting blueprints to code, which is going to make it faster and allow us to access it from more places. But then we're also going to be cleaning up our animation blueprint as a result of our work in our projectiles. First things first, let's go to our mutant anim BP so that we can see what we're working with here. So if we go to the animation blueprint for our character, we can search for some events here related to where we're going to spawn our projectiles. Now I think an anim notify to spawn a projectile is perfectly fine, because at a certain part of an animation we may choose to spawn a projectile. That makes perfect sense to me. So we were spawning the actor, we were creating a hitbox for it, and then we were calling a custom function that we made called spawn projectile, which is really what happens when we are ready to assign all the values to our projectile. So the name is slightly misleading, as we technically spawn the class here, but this is where we're filling out the properties and actually starting the behavior for that projectile. So this is a three-step process here. What I would like to do is assign the values to the projectile. We can create the hitbox separately, and then we can still call a function here to set up the projectile and do any additional behavior. But I don't want to have to call this manually every time. I want to use our function that we made in the previous episode. And if you didn't follow that, it's okay. Basically, I want to use this setup where we're creating projectile hitbox based off the data table elements, and then automatically spawn the projectile based on the passed in one here. Don't worry that this blueprint is ugly. If you didn't watch the previous episode, this is something I said I was going to clean up, and we are going to clean it up. I had two different methods in mind for this function, but we're not going to do that yet. We're going to wait until we have our projectiles ready, and I'll show you why when we get there. So with this in mind, we now know what we're going after. Let's go to our base projectile blueprint. So if we go to content, blueprints, functional BPs, projectiles, we have a few different types in here. The main one I want to focus on today is default projectile BP. When we come in here, we see that we have a spawn projectile custom event that we added to our default projectile BP, and this means that children of default projectile BP, which is going to be all of these classes here, will be able to use this event, and you'll see that they do. If I go into projectile homing, we have event spawn projectile. But we could easily put this in the code class so that every projectile has this, and we don't need to put it in the default projectile BP, as this is kind of obscuring logic. If we put it in the code class, we can access it from anywhere, anytime we have a projectile. Same with force destroy here. Force destroy is an event that we have that will allow us to manually destroy the projectile at any point. So say the projectile's lifetime is not up and it hasn't collided with anything, but we met some other condition specific to that projectile, tells us we should destroy it. We would call force destroy. Even event tick here, this tick logic is very simple behavior. We do not need to be doing this in the blueprint. We can do all of these things in code, which would allow us to have an empty default projectile BP, and we wouldn't need to go into Blueprint to spawn these things or link to a Blueprint class if we wanted to do any of this in the code. Additionally, we do have 2 variables and a few components that we could move to code as well. Nothing in the construction script. So I just want to go ahead and convert these events to code, and we'll replace the event tick logic and convert that to code as well, and we'll go from there. First things first, spawn projectile. So if we go to our code, we can go to our base projectile.cpp and base projectile.h. And specifically, let's start in the header file. And in here, I want to make our spawn projectile function, but I'm going to call it something else. Let's call it initialize projectile. That way it's like we're filling out the data for it, and then we can also do any logic that we want to be specific to the projectile once the data is filled out. So initialize the projectiles data, and begin initial behavior. And so we can make this a U function that is blueprint callable so that we can still call it in all the places we were calling it, such as the N and BP. You'll notice that I'm putting this in public so I can call it from other classes, not just children of a base projectile. And we will call this void initialize projectile. And after that, we should have a force destroy. I like that. But I'm also going to change the name here to just void destroy projectile. I think force destroy is good because it can be destroyed by other means. However, if we just call it destroy projectile, that also should work regardless of where we are. So I think this is perfectly fine. Destroy the projectile and perform any needed cleanup. We'll make this a U function of blueprint callable as well. Now, these functions are perfectly fine being in here. They don't match the name of spawn projectile and force destroy. We'll have to replace them. But something super important about this is we need to be able to override them in the children classes. If children of this class, such as our default horizontal or default homing, or projectile spear, any of these projectiles, if they are going to use these functions, then we need to make sure that they are overridable. And to do this, we can just add the virtual word on top of it. So virtual void initialize projectile and virtual void destroy projectile. This will allow the children to override these and do their own behavior in them. And even if they don't want to override them, if we have default behavior in either of these functions, then the children will get those sets of behavior for free. Now, if we go into base projectile.cpp, we can fill out the behavior for these functions. And I'll clean up this class a little bit while I'm in here. Also, you'll notice that we already have tick overridden in here. It is virtual, so the blueprint child, the default projectile BP, can use it, and it does. We can also fill out the behavior in the code for it. Okay, so if we go to base projectile.cpp, and I will put my functions down here, we want to make void a base projectile initialize projectile. And we want to come down below that one and make void a base projectile : destroy projectile. And they don't have to have anything in here. Like, for example, the default BP doesn't have anything in here, so there's no default behavior for projectiles. Each projectile is different. So you could completely leave these out, make it pure virtual, meaning everyone has to override it. Or you could leave it open and just empty braces here so that the parent just does nothing. That's also fine. I'm going to leave it like this. I think this makes sense for now. We may want to do more with it in the future. And that's pretty much it. Now, some personal things. I don't like to have set up player input component tick. I like to put that right next to my constructor, because that is the order of which these things get set up. You can leave tick here if you want, but I actually like to put tick at the bottom of my class. It's just something I've always done. You don't have to do this. I don't think it's standard or anything to do this, but it's just some way I set up my classes so that I can pretty much always find it, and you'll notice I do that a lot. I did not do it in here for some reason, so I'm just doing this for me. You don't have to follow this, but I figured I would include it in case you want to, and also so it's not so confusing. If you look back at this a couple episodes later and you're like, why did he do this? Just personal preference. So anyway, with that done, we can now start copying the logic of tick over into the code function. So you'll see in default projectile BP, we have event tick, and we're checking to see if the custom time dilation is greater than 0. But this is actually a pretty useless check, because custom time dilation is the time dilation for this actor. It essentially acts as a multiplier to tick. If the custom time dilation is 0, then we're not going to be ticking. You don't need to check these values. So this is really an additional check that does not need to be here. Feel free to just remove this. You'll get this new blueprint logic here. Our projectiles have a lifetime. This is essentially how many ticks they can take before they're destroyed. So the lifetime in frames of the projectile. This is already in the code. And what we were doing with it in the blueprint is just subtracting from it every tick, checking to see if after subtracting from the lifetime, if it's still greater than 0. And if it's not, meaning it's 0 or fallen below 0, its lifetime is up. So at that point, I was getting all the attached actors because the hitbox is attached to the actor. I was destroying the actors, and then once we destroyed all attached actors, I was destroying the projectile as well. We can do this very easily. So below super : tick, we can grab our lifetime and decrement from it, or we can actually do a pre-decrement in this case. Pre-decrement is technically a little bit faster, and it really does the same thing in here. We're just going to reduce the lifetime. Reduce the lifetime of the projectile. And if the lifetime is less than or equal to 0, this is an integer since it's in frames, so we can do a direct check against 0 here. Then we want to call destroy projectile. That's not technically what we're doing in the blueprints. We're just manually destroying the actor. However, we have this force destroy, which I'm now calling destroy projectile in the code. So if we control F, search for force destroy under the binoculars, which searches in all files, do we use it? And you'll see that we do use it. We have it here in our default projectile BP, which is the event itself. And then we have this up from ground projectile, that's our little flaming tornado. And we have a call to it here. Once the timeline is done, destroy it. And you'll notice that we override force destroy here to go through and destroy any hitboxes that are attached, and then destroy the projectile. So a couple things about this. This is doing the exact same logic as the parent. So there's no reason to override this and do our own behavior here. And second, we don't need to just be manually destroying the actor in both of these classes. We can just have force destroy do this behavior, and then it would simply look like lifetime decrement, if it's greater than 0, false destroy projectile. How I have it here in the code is good. So now destroy projectile is going to take on the role of checking the attached actors for a hitbox actor, and if it exists, destroying it and then destroying the projectile itself. I'm going to go one step further. So the projectile up from ground was only checking for the hitboxes as attached actors, but I do think anything that's attached to this actor should also be destroyed at this point. You could change that per actor. So if you had a projectile that spawned other projectiles, for example, and you did not want them to be destroyed when the parent was, that's perfectly fine. You could override the force destroy or the destroy projectile in that projectile. But for the default behavior, I believe we should destroy all actors that are attached to this actor. So if we go back to the code here, we can get attached actors. And the way this works is you pass in an array. The array will be filled out with all the attached actors. So we can make a T array above this, T array of a actor pointer. We'll call it attached actors, and then we will pass in attached actors. Retrieve all attached actors. Here we can just loop through them and destroy them. We can do either a for loop or for each loop here. Either will work. So for a actor pointer attached actor colon attached actors. So for each attached actor and attached actors, we can check to see if the attached actor is valid and if attached actor is pending kill. This first check is just making sure it's valid. It's not a null pointer, which it shouldn't be at this point, but if it was being deleted somewhere else, it could be. So it's good to check it right before we destroy it. And then additionally, when we check for is pending kill, we're doing this because if it's being cleared by garbage collection, it's already marked for delete, you could actually still crash. If we're pending kill, we don't want to destroy this. So, excuse me, put an exclamation mark here. If attached actor, so if the actor is valid and not is pending kill. Because if we're not pending kill, we're able to be destroyed. So this is a safe way to delete it. And it's okay to delete it in a for each loop like this because when we call destroy actor, Unreal will be the one to mark it for delete in its garbage collection and it will handle it safely. So you could just go attached actor, destroy. Another way you could do this is by using a destructor and destroying the attached actors, or using one of the overridden functions like when the base projectile is destroyed. One benefit you could get of doing it this way as opposed to doing it in a destructor or something like that is if you want to have other things in here like playing an effect and you don't want the object to actually be destroyed until after that's done, you could trigger other things in your destroy projectile function. But that was a lot of information. Basically, all we need to know is that we're destroying the projectile once the lifetime runs out, and then we can also call destroy projectile anytime we want to destroy the actors attached to this projectile and the actor itself. And at this point, we're good to go. We can go ahead and launch the editor. Now, the editor is back open, so if we go to default projectile BP, we don't really need this tick anymore at all. We've done everything in here. I mean, we can remove it and make sure that it still works with our new tick. Now, we don't need force destroy anymore either. However, we need to make sure that we replace all references here. So force destroy, if we go ahead and search for that one again, force destroy. I know where it was being used, but use your binoculars. Everywhere it's being used is able to be successfully replaced. So, projectile up from ground. Again, this is our fire tornado. You've probably seen this attack if you've been following the series. But it doesn't really matter where I'm at. If you're using this function anywhere, go ahead and replace it with a new function we made. Additionally, in this file, we don't need to have an override of force destroy. Everything we're doing in the parent class will be sufficient for this. So if you choose not to override it at all, we'll just mimic the behavior of the parent, which will work for this. You could choose to make a parent call to force destroy, which you could do by right-clicking on event force destroy and add a call to the parent function. At this point, you would just link these two nodes up and it would work. But there's no need to do this either because, again, if it's excluded here, we will automatically use the parent behavior, which is what we want. Now, in spawn projectile of this up from ground projectile is where we were calling force destroy and specifically on finished of the timeline. Now we can instead call destroy projectile and we can remove force destroy. But we can compile and save and go back to the default projectile BP. This means there's no more references to force destroy, so we can remove it. The other function in here is spawn projectile, which all of our projectile children are going to use. Now with this one, we won't be able to remove it. And the reason for this is because if we look at our code, we have void initialized projectile. To override behavior in C++, we need to make these functions virtual, like so. This will allow us to override them, just like you see on something like tick. And that means that children classes can implement their own version of this function. It's not so simple to just add virtual on a function and allow Blueprint children to override it and put in their own behavior. And we could explore some of those. It would be too much for this one episode, but what we can do for today's episode is make this a Blueprint implementable event. We can either go the route of making C++ classes for each of the projectiles, making this a Blueprint implementable event, or something else, but Blueprint implementable event is not necessarily the route I want to go. However, it's significantly closer to the final result we're going to have in our projectile cleanup episodes, because I want to be able to do these things from the C++ side or the C++ projectiles. I don't want to have to use a Blueprint projectile or access the Blueprint to do these things. But instead of rewriting all these projectiles right here, right now, we can just do this as a nice compromise for both. If we go the blueprint implementable event method, then we need to go back to our base projectile.cpp and just comment out our function definition here, because if it's a blueprint implementable event, it cannot have a function body in code. Then load up your editor again and go to your default projectile BP. In here, we want to replace everything with our new function that we made in the code. So instead of spawn projectile, it's going to be initialize projectile. So we can control F or go to the find results section, and then we can also find in all blueprints and look for spawn projectile. Everywhere we see this, we want to replace it with initialize projectile. So I'm just going to go down the list and change them out one by one. So we're starting here with projectile horizontal, which is our fireball, and it's also the parent for our spear. Just replace spawn projectile with initialize projectile. Next one is up from ground, which is our fire tornado. Replace spawn projectile with initialize projectile. Homing projectile, same thing here. Replace spawn projectile with initialize projectile. Then we have our spear projectile, so we can replace spawn projectile with initialize projectile. And I forgot why we needed the parent here. I forgot that the spear was a child of horizontal projectile, so I ended up taking out the parent call here. You're going to see when we test it why that does not work, and we're going to add it back. But for now, you can just set it up how I have on the screen, and we can test it together. And then the last ones are in the animation blueprint. So we can go to our anim BP, and wherever we're calling spawn projectile, we just want to call initialize projectile instead. We need to drag off of our projectile reference to actually get this, and I'll do some minor cleanup while we're here as well. But there's going to be one for each of our projectile types that we spawn, so just change spawn projectile to initialize projectile for all 4 of these. So that was the horizontal projectile. The next one is our up from ground projectile. Same deal, just change spawn projectile to initialize projectile. Perform some cleanup. Then we have our homing projectile. Of course, change spawn projectile to initialize projectile. And then we will get to our spear, which is the last one here, and we're going to change spawn projectile to initialize projectile and clean it up. So very simple stuff here. We're just making it a little bit nicer, a little bit easier to use, and preparing for the future episodes of cleaning up the projectiles. At this point, you can go ahead and remove spawn projectile from default projectile BP. Everything should be using initialize projectile now, so spawn projectile can go away. At this point, you can go ahead and test all your projectiles. They should all work except for the spear. We need to go back and call the parent function for initialize projectile, and you'll see why we have to do this right here. We're relying on the behavior from initialize projectile in our homing projectile to actually apply force or movement, otherwise the spear just gets stuck in place. So go back to your projectiles, go to projectile spear, and in initialize projectile, we need to call parent initialize projectile. And you can do this by right-clicking on initialize projectile, add call to parent function, and then hook it up. And this will fix the spear. We can go test it and confirm, but I know it will. So testing the spear again, you'll see it's being applied in the wrong direction, but that's another issue, so our spear is working. Now if we try our up from ground, we'll see that it never gets deleted. This is an issue for all of our projectiles, and it relates to our destroy projectile function that we made in the code today. Even though we destroyed all attached actors, we never destroyed the parent actor, the projectile itself. We need to go down below our for loop after destroying the attached actors and just call it destroy. This will destroy the projectile. Otherwise, it will never be destroyed when we expect it to. Do this and go ahead and test again, and you should see it dies after its lifetime is up. Hopefully you enjoyed this episode on cleaning up your projectiles and making projectiles in C++ with your fighting game. If you did and you want to see more content for the fighting game series, then please subscribe. It does more for myself and the channel than anything else you can do, and I really appreciate it. I want to give a huge shout out to my YouTube membership, Patreon members, and Discord subscribers. Thank you guys so much for all the love and support. I'm incredibly grateful for you. If you ran into any problems following this tutorial or any of my tutorials, feel free to join the Discord community. There is a link in the description, and I would be happy to help you out. Thank you guys so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.